Hey everybody, it's Mrs. Lecheminant, and I get to present to you all about Newton's first and second laws this week. So, for starters, Newton's first law. As a quick reminder, a law is something that happens all the time, like the law of gravity. You can't just decide one day that gravity doesn't own you anymore and float off into space. It's always going to be there. That's the same for Newton's laws. So, this is Newton's first law. The first part of this law is that an object at rest will stay at rest unless an unbalanced force acts on it. I have two objects presented here. I have a soccer ball and I have a pitcher of lemonade. So, this idea that an object at rest will stay at rest unless an unbalanced force acts on it is this. Basically, these two objects are never going to start moving on their own. In order for them to stop being at rest or staying still, you have to apply some kind of a force. A soccer ball, maybe somebody comes along and kicks it. They add enough force to to start moving the soccer ball. That is an unbalanced force. It's enough force to actually make something start moving. So a soccer player could come and kick that soccer ball and it's no longer at rest. You have added a force. Same with the pitcher. If you decided that you went over and wanted a glass of lemonade, you could pick it up and start pouring yourself a glass, and that is adding enough force that it's no longer at rest. The second part of Newton's first law is kind of the opposite. If an object is in motion, it will stay in motion unless an unbalanced force acts on it. This always makes me think about space. In space, you don't have as strong of gravity as you have here on Earth. There's virtually no air resistance and almost no friction. Between those three different concepts, that's usually what stops motion here on Earth. If you were to take a softball or a baseball and throw it in space, because it doesn't have gravity acting on it, because there's no air resistance or friction, potentially that baseball is going to continue moving at the same speed and the same direction forever. Now, the only thing that would really change that is if it collided with something or ran into something, or if maybe it got too close to a planet and the gravity from that planet or even a star started pulling that object in, it would change its motion. So, unless you add a force, an object is either going to stay in place forever or it's going to keep moving in the same direction and at the same speed forever. Something that goes along with this first law is a concept called inertia. It's basically the same as Newton's first law. The law of inertia, the Newton's first law, basically the exact same thing. Specifically, though, inertia is talking about an object resisting change to motion. So the laws are more of like, if it's not moving, it doesn't want to move. If it is moving, it doesn't want to stop moving. Inertia is kind of the idea behind why it doesn't want to change its movement. If an object is not moving, they don't want to start moving. Think about all those days when you get yourself nice and comfortable on that living room couch and you're about to watch your favorite TV show, but you realize the volume's not high enough and you forgot the remote. You don't want to get up to go and get that remote after you've already been super comfortable. On the opposite side, if an object is already moving, in a lot of ways, it's actually easier for it to stay moving. So, if an object is not moving, it doesn't want to start moving, it resists that change to make it move. Or if an object is already moving, it's kind of hard for it to want to stop moving. You could think of this little girl and this elephant for the first part. This elephant is not moving. This little girl is pushing as hard as she can. Is that elephant going to want to start moving? Probably not. There's a lot of resistance. That's inertia. If you were to flip the scenario, if this elephant was running and this little girl was pulling on its leg to try to make it stop, there's a lot of resistance keeping it moving forward and preventing it from stopping. Inertia is resistance, making it harder for it to either start or stop moving. Inertia depends on mass, and mass is the stuff that makes up an object. So basically, the idea is that if you have more mass, there's more of a resistance or more inertia to changing its direction. If this little girl were to start trying to push this shopping cart if it was sitting still first, it's harder to start it moving. Once the shopping cart starts moving, it's harder to stop it. On the flip side, if there's less mass, you could think of like an empty shopping cart, it's actually much easier to start moving or change the direction or stop that shopping cart because there is less resistance to that change, less mass, less resistance, less inertia. If you look at these two examples, which object has greater inertia or greater resistance? I have an empty swing that's being pushed by a little girl, and here is a swing that has somebody in it also being pushed by a small child. The answer to which object has greater inertia or greater resistance is this swing over here. The mass or the stuff that kind of makes the whole swing up is much greater than the mass of this empty swing set over here. So even though the two children are pushing probably pretty close to the same amount, this is going to resist the push more just because there's somebody sitting in it, which adds mass to the swing set. Newton has a second law. He also has a third, but we're only going to talk about the first two today. Newton's second law states that acceleration, or a change in your speed, basically a change in your movement, depends on the force, or the push or pull, and the mass, or how much stuff is inside of an object. So as an example, I have a toy car over here being pushed by a small child. I have a large adult-sized car being pushed by an adult. Which car would have greater acceleration? Which one would speed up faster? The answer would be the toy car. Even though this child has a weaker force, which means that the child is not able to push as hard as the adult, so a weaker force, the mass or the stuff that makes up this car is a lot less than this actual car over here. So the acceleration would be much higher for this little toy car than it would be for here, just because it has basically a greater force for the amount of mass there is. There's a lot of mass over here, there's a smaller force, so this car is going to start moving forward very slowly. And that's what Newton's second law is. If there's a lot of force and a little bit of mass, like over here, it's going to start accelerating very easily. If there's a lot of mass and a small force, it's going to accelerate very slowly. So over here, I have an example. I have a lady on a bike. If she were to go along, she's biking over to the right, and suddenly she runs into a curb or a pole or something that she didn't see, which direction does her body want to keep moving even though the bike stopped? The answer is that she is going to fly off of her bike and continue moving towards the right, because that is the Newton's first law. An object that is in motion wants to stay in motion. So inertia is resisting that change, that stop of the bike, and it makes her body continue moving. So in summary about Newton's first and second laws, inertia and everything else, Newton's first law says that an object doesn't want to start moving if it's not moving. Also, that object does not want to stop moving if it's already moving. You could especially think of like an astronaut or some object in space. Inertia is basically the same as Newton's first law, but more specifically, it means that an object resists change in its motion or acceleration. If an object has more mass, think of like that full shopping cart, it has greater inertia or stronger resistance to changing its direction or starting or stopping. On the flip side, if there is less mass, think of like that empty shopping cart, there is less inertia or less resistance. It's easier to start it or stop moving it. Inertia, think of that plane, basically always acts in the opposite direction of acceleration. If you're sitting on a scooter and that scooter starts accelerating you to the right, your body almost wants to go to the left because it wanted to stay still.